Good morning, children. Hope you all saw your test marks, which I had sent through WhatsApp. I would say the performance was fair, not very good, not very bad. Being the first test, it's fine. Most of you had done well, and I would encourage you to keep doing well so that you can score good grades. Okay, so we'll continue with the sound chapter that we started the in the previous video. And this chapter has few changes because in your book what they have given is not very clear, so I'm going to give you the notes. Okay, so what you do, you can strike off this. Okay, till this point you will study, and you have written question answers also based on that. This point you can strike, and this characteristics of sound wave also you can strike. Okay, and till the next page. Okay, so you can strike off these two pages fully, plus this page. From here you can strike it off. Okay, so we will be doing it. Yeah, so we'll start with characteristics of a sound wave. Okay, I'll be giving you notes. You have to follow what I'm teaching. First you listen to what I teach, then you can write down whatever I tell you to write. Okay, the first one is, we are trying to understand a wave motion. Sound travels in the form of waves. Okay, sound travels in the form of waves. Wave is something, a pattern that repeats after a particular time. Okay, wave is something like that. Okay, now you all would have seen ripples. Now suppose there is a lake. Okay, there's a lake and with still water. The water is very still, and you drop a stone here. Okay, you're dropping a stone. Now you would feel that, or you would see that, you will see ripples forming like this. Okay, you will see ripples. Okay, around this stone you will see ripples forming like this. Okay, something like a wave. Okay, so it will die off after some time. Now these ripples, okay, if I draw it like a wave, now suppose, to understand it, suppose imagine you put a stone here, and then you keep a paper or something light. Okay, you keep a paper or a cork. Okay, a wooden cork or something. When you keep it, so as the ripples are formed, this also will move up and down with that, because this is very light, it won't sink, it will keep floating. So along with this ripples, this will also move. Okay, now I'm going to show you a kind of wave, how this will move. Okay, now if you would have seen, it will be actually moving like up and down, up and down, up and down, like this. Okay, if you see carefully, the paper or the whatever it is, it goes up, then comes down, this comes down, up, down, up, down, up, down. Okay, this is called a wave. Okay, so if I suppose represented, this is water surface, and then this cork or the paper will go up and down, up and down, up and down, like this, and after some time maybe it will stop. This movement will stop. Okay, so this kind of pattern is called a wave. Okay, and sound travels on the surface of medium, in this surface of liquid, like this form of a wave. There is another form of wave also that you'll be studying in 9th standard. Now you just understand, on surface of water the waves will travel like this. Okay, now that wave itself, I'm going to draw it um, in a much clear way in the form of a graph. Okay, so graph means, you know, there's an x-axis, there's a y-axis. On the x-axis you have time. Okay, now I'm going to draw a wave. Okay, so okay, this is a wave, it keeps going. Okay, I'm just stopping with two waves, so this pattern will keep repeating. Now you need to understand a little bit about the sound wave. Okay, this is a sound wave, and we are going to understand few things in the sound wave. First is these points. These points are called crest. Now actually, if you see that paper or something, it will go up, come down, then go down, and then come up. So that's how it goes, right? Goes up, comes to, okay, this is the mean position. If you take, it goes up, then come to the normal position, then comes down, then again come to normal position, then go up, then come down. So that is the kind of repetition it has. Okay, now there will be a, this is positive side and this is negative side in a graph. You all know that, right? This maximum displacement on the positive side is called crest. This point is called crest, and the maximum displacement on the negative side is called trough. Okay, the maximum displacement, okay, in this negative direction or displacement in downward direction is called as trough. Okay, so this wave has crests and troughs. Again, crest, trough, like that it will go. Now the next thing you should know is, okay, one crest, okay, one wave will have one crest and one trough. Till this we say one wave. One crest followed by one trough forms one wave. Again, this is the second wave. Okay, okay, till this the second wave. Then again, okay, this, don't think that this is not one wave, this is half wave. Okay, one crest and one trough together forms one wave. One crest, one trough, one wave. One crest, one trough, one wave. Okay, like this it keeps going. Okay, the next thing you should know is amplitude. Okay, this distance from the mean position to the maximum distance, that is called amplitude, represented by letter A. A stands for amplitude. Okay, this point is C and this height is A. Okay, then this one, this length or this is called time period, capital T. Capital T stands for time period. Okay, what is time period? This is the time taken for one oscillation. Okay, one wave. For one wave to occur, the time taken is called time period. For example, when you draw a graph, suppose imagine this is 0 and this was 0.25 seconds and then 0.5 seconds, then 0.75 seconds and then 1 second, 1.25 second, like this it's going. Okay, now what will be the time period? Time taken for one wave. So time period of this particular wave is 0.5 seconds. Time period of this particular wave, I'll say 0.5 seconds, because one wave completes in 0.5 seconds, so you call it as time period. Okay, children? Okay, so amplitude is one term. Okay, the displacement, maximum displacement from the mean position is called amplitude. Time period is time taken for one wave, and then there is another term called frequency. F, okay, frequency. F stands for frequency. Frequency means how often. For buses and all they say, how frequent is the bus, means how often the bus comes. Okay, frequency means number of oscillations in number of waves produced in 1 second. Number of waves produced in 1 second. So in this 1 second is here. How many waves are produced in 1 second? 1 and 2. So the frequency of this particular wave is 2. And the unit is hertz. 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 Okay, this is named after a scientist. But we need not write the full uh, name. It's enough if you write capital H and small z. Capital H and small z. Okay, you can write like this. That's called hertz. 2 hertz. Okay. So these are the 3 important terms: amplitude, time period, and frequency. Now another thing you should know about frequency is 1 upon time period. Frequency is generally 1 upon time period. See, in this case, time period was 0.5 second. So 1 upon 0.5 seconds. That will be into 10 into 10. So it will be 10 upon 5. That will be 2. You get the same answer. That is the frequency also. Okay. So this is also another way to find frequency. From the graph you do like this. If it is from the formula, you will do like this to get the value of frequency. Hope you have understood this, children. Now you're going to take a notebook and you're going to start writing along with me. Okay, pause the video, go bring your notebook, get a scale pencil also. We might have to draw one diagram also. Is it clear? Okay. So write the heading as sound wave. Sound wave. Okay. And then you write a sound wave can be represented by the graphically as below. Okay, a sound wave can be represented graphically as below. So now we're going to draw the diagram. Okay, so what you do, you take your scale. Okay, so first you draw a horizontal line like this. Okay, little long line. Then you draw a vertical line like this. So it's like a graph. Okay, x-axis and then y-axis. You don't write x and y, but you should write on x-axis, you should write time. You're taking time on the x-axis and displacement on the y-axis. That's okay. Now what you do, the wave, as I told you, it should have this will be equal. This distance, all these distance has to be equal. So what you do, maybe with a scale, you mark 2 centimeter, 2, 4, 6, 8 and 10. Okay, now with a pencil, or you can draw this also with a pencil, whatever it is, take 2 centimeter above and 2 centimeter below, and then draw a dotted line, in the sense very light line. Okay, it need not be seen outside. It's just for your just for you to know that the wave should not cross this point. Okay, so you draw a very light line or a dotted line like that. Now you start drawing the wave. Okay, so it should go like this, then come like this. Okay, then it should go like this, sorry, maybe like this, then like this, then is it clear, children? This is how you draw a wave. Okay, on the y-axis please write displacement. Okay, x-axis time, y-axis displacement. Okay, now we start marking this graph. Okay, what you do, you mark this, okay, this point, and write letter C. Okay, mark this point and write letter T. Okay, and then below you write C is crest. Okay, T is trough. T-R-O-U-G-H, trough. Is it clear? The next thing you can mark is amplitude. So what you do, you draw a line, put arrows from here to here and write the letter A. And then here you write A is amplitude. A is amplitude. Then this will be time period. Oh, that also is T. So you better write it as trough only. Okay, leave this, children, leave this off. Here itself you write crest and trough because there's another T coming here, that is time period. So T will be time period. Is it clear? Okay, pause the diagram, pause the video wherever you need and draw this diagram. This is the graphical representation of a sound wave and crest, trough, amplitude and time period. Now we are going to write the definitions. Okay, definitions of these terms. So write the heading definition. First one, amplitude. Amplitude. Okay, and it is represented by letter A. Amplitude is represented by letter A. So the definition of, I'm sorry children, first is not amplitude. Sorry. First definition is crest. First is definition of crest. C-R-E-S-T. So what is a crest? It is the position of maximum upward displacement. Maximum upward displacement. Second, trough. Second is trough. Second term you should know is trough. What is trough? It is the position of maximum downward displacement. Maximum downward displacement. Okay, the third one we will write amplitude. Amplitude, A-M-P-L-I-T-U-D-E, amplitude, and symbol is small a. Okay, so what is the definition of amplitude? It is the maximum displacement of a wave. Displacement means how high it goes. Okay, of a wave on either side of its mean position. Okay, this also is amplitude. Okay, the lower, this also is amplitude. So maximum displacement on either side. The maximum point is this one. So this height, and on this downward side, this height. They are amplitude. Next, this is the definition, and another information you should know is its unit is, or it is measured in meter. Okay, meters, or symbol is M. Is it clear, children? Now come to the fourth definition. time period. Time period represented by capital T. Okay, this is small a, this is capital T. It is the time taken to produce one wave. Time taken to produce one wave. Okay, and its unit, okay, because it is time, its unit will be seconds. In symbol you will just write S. Okay children, then comes the fifth term, that is frequency. Frequency. Frequency, symbol small f. Symbol is small f. Definition is, it is the number of waves produced in 1 second. Number of waves produced in 1 second. Its unit is Hertz. Hertz, or short form it will be Hz. So every time when you write the unit, you need not write the whole word. It's enough if you write Hz. But you should know what is Hz. Okay, Hertz. Okay. The sixth one, one wave. Okay, one wave. I'm sorry children. Before this, please write time period T is equal to 1 upon frequency. Time period T is 1 upon frequency, or you can say frequency is 1 upon time period. Both are correct. Okay. Now comes the sixth definition, that is one wave. One crest and one trough form one wave. Okay, this will not have unit and all. This is just one wave. Means what is one wave? One crest and one trough together form one wave. Same way, crest and trough, like the crest and trough definition that we wrote. The crest and trough definition that you wrote, again it won't have unit and all, because this is just position. This is this point is called crest, this point is called trough, and this is called one wave. Okay, but amplitude and all, you can measure it. That's why you need a unit for it. Amplitude, measure it in meter. Time period is measured in seconds. Frequency is measured in hertz. Frequency is measured in hertz. Frequency is measured in hertz. Whereas this won't have any unit. This is just a definition, that's all. Is it clear, children? So today's homework, you don't have any homework basically. Okay, all that you have to do is write these notes neatly. Okay, the same way as I have been dictating, write it neatly, click a picture and send it to me. Okay, the sound waves diagram followed by all these 6 definitions. Okay, rest of the part will continue later. Thank you, children.